So, remember yesterday, the fundamental theorem of calculus is kind of our definition that relates to antiderivatives and derivatives, right? Well, the part 2 of that is something that will define an integral as a function that calculates area. Okay, so basically what you have would be something like this. And what the function is going to output when you calculate the value of that is an area. So this is the signed area from x.
So if you have an acceleration, like you have a empty, and you integrate that, you get the average rate of change from A to B. Is that how it works?
You get the change. No, you get displacement.
In velocity.
Oh, you're talking acceleration. So
If you go from
yeah,
acceleration to velocity,
exactly.
average rate of change? Or is it?
It would be the velocity change over the interval. Yeah,
So average
I
rate of change.
think. No, just the change in velocity. It would not include dividing by time. So average rate of change requires you to divide by time.
Yeah.
When you calculate an integral of acceleration, you are just calculating the change in velocity.
So you get average rate of change from that, you just
Divide by
B
b minus a. Yeah. Okay. Another neat thing that we can do here is the derivative. As long as so that's basically an extension of the fundamental theorem of calculus using the antiderivative and the derivative relationship. Okay. And this is the thing that the AP likes to test the most. Okay, and I'll show you an example of that here in a bit. Okay.
I don't understand the A of A equals 0 part.
So, normally when you evaluate an integral, you'll have like f at x minus f at a. Right? Well, as long as that is 0, we don't have to worry about it. When you evaluate, so if you subtract 0 when you evaluate,
Yeah, I don't know.
okay. What they're saying basically is if a is 0, okay, or the area function at a is 0. You will have any value that's outputted.
So as long as the position at A is 0.
Right.
Okay.
Yep. Okay. Let's do a couple examples and we'll move on to the meat of it. Calculated derivative. So, what's the derivative there?
Root 1 plus t cubed.
Root 1 plus
T cubed. Not x cubed.
x cubed. There you go.
What in the heck?
So remember
Like derivatives cancel integrals.
the antiderivative and derivative relationship
Yeah, but why in the heck did you change the variable?
because we have a variable here. When you evaluate that, the x will come in.
So what if that wasn't an x, but it was like a 4?
Then you would have to do a prime at 4 minus, like you put 4 in here,
Oh,
right?
yeah.
It's like a normal integral. When you evaluate, you put a at 4, a prime at 4 minus a prime at 2, correct? The nice thing about the fundamental theorem of calculus is that you can sidestep all that work.
By just putting in the x?
Yeah, or whatever's there. I mean,
Right.
now, back to your question about this,
Yeah.
right? A at a is 0. Okay. What is a at 2? Because that's what value we have here, right?
Yeah.
So what is a at 2?
3.
It's the integral from 2 to 2.
Oh.
What's
3 minus 3 is 0.
at 0? Because there's no x value change, right? That's why that condition here allows us to not have to put anything in the back when we evaluate.
But when at 8,
Because so basically this would be a from integral from a to a, which creates 0 thickness in your area,
okay.
right? So you have nothing to, right? What's a prime at 2?
2, 3.
Yeah. So you can go on and calculate all sorts of values there, and this is a very popular AP free response question. You're given a function that's an integral, calculate the value of the function, or derive the function, calculate values, etc. Okay. So what about this? Okay, what do you think the derivative is?
Sine x squared.
You're half right.
Plus 1.
Nope. What do we usually have to do if we derive?
Oh, it's chain rule, so it's 2
There you go.
x.
This is a chain rule issue because we have an inside function now. We've derived a function with an inside function, so we have to chain rule
I
that.
don't ever remember doing this much here.
You guys didn't get it. You didn't understand it. So, yeah, it's not, it's kind of funky. It took me a long time to understand this.
So what's the purpose of this? Like,
Oh, just to give you more work to do.
nice.
Yep.
Nice.
It allows you to work with an area function. So, like mathematically, like you're given an area, a graph,
Oh, I see.
right? And you can work with the area of that in different ways.
How would you do that one? Because like, they don't give you an equation for that, they give you a graph.
Different ways. They do give you one for g though. So g of x is the area from -3 to x of f of t. Okay, so we do have an area function now. So G is defined by whatever area we get here, assigned area, right?
Yeah.
That's what that means.
So you wouldn't derive G of X.
So if I start at -3 and go to -1, the value of G is the area of that triangle. Okay. So, okay, so if you were asked to find G at 3,
So from -3 to 3.
Good three.
yeah, it's the, basically the area from -3 to 3, right? You get whatever, 1, 2, 3, those are, correct. We can put, what's that, 1? 3 times 4 is 12, so that's 6, right?
How would you include the -5 to -3?
Oh, I did -5, didn't I? We could still make that useful at some point, I bet you. So we're only going from here to here. Oops,
And then
lost my point of the AP exam. All right, what's that area?
Negative half, right? So 1 by 1 triangle, or am I blind?
Yeah, it's 1 by 1, so that's a half. So 6 and 4 is 10 minus a half.
9.5.
So pretty straightforward, right?
Yeah.
Yeah, just calculate the area. Okay, on what intervals contained in -5 to 4 is the graph of G both increasing and concave down?
You'd have to derive G of X.
Okay, so G is, that's a good idea. So what is G prime?
To
F
derive
of
that.
T.
F at
X.
X.
So it's just the graph. of
Yeah.
that.
The values of F. So where do we know that G is increasing?
-3 to 0.
G prime is positive, right?
Yeah.
Which also means that F is
Oh,
positive.
so I would have gotten that wrong.
Exactly, so you gotta be paying attention here. So where is F positive?
-5
So
to
this
3.
-5 to 2. So G is increasing. Right? Okay. And then how about concavity? G double prime X is F prime, right? So where is G double prime less than 0? We want F prime to be less than 0, right? So that's concave down.
Yeah.
So where is the slope of F negative?
-3 to, or -5 to 3, and 0 to negative, or to 2 to 4.
Yeah, this is, G is concave down. So where are both of them matched up? From
-5 to 3.
-3 and 0 to 2. Yeah, so always write this statement here and this statement here. They'll actually look for it when they're scoring your exam. Okay. So you're connecting the two, and that's a reason for your answer. See, we just wrote a reason mathematically for my answer.
That G prime X equals Fx throws me off though. It's like, I don't know, that just immediately makes me think that they're the same, but it's the values.
Right.
That's,
Yeah. They're equivalent statements. The function h is defined by h of x as g of x over 5x. Find h prime at 3. If you can handle that.
I feel like this was a hard problem, huh?
It's hard if you don't understand the relationship of the fundamental theorem of calculus, right? But if you do, these are points bonanzas, like bust it out and get a bunch. Right? So h prime is
5x times g prime of x minus g of x times 5 over 5x squared.
okay. Good, you just earned 2 points. That's
And
quotient rule,
plug
right?
in 3.
Yeah. So g prime at 3, we should already have the answer, right?
9 and 1/2.
9.5.
That was for G of 3, not G prime 3.
Yep, you're right.
So we haven't found G prime 3 yet.
Would it be the value at f at 3?
Yep. Okay, so G at 3. Sorry, G prime at 3,
-1.
so remember G prime at 3 is F at 3.
So -1.
So F at 3 is -1. Yep. There you go, there's your answer, don't touch it. Right. Yeah. Okay. All right, and then part D, so this is C. So P prime, so we want slope of the tangent line, we need P prime, right?
Yeah.
Chain rule.
F prime. Oh, x squared minus x times 2x minus 1.
Derive outside, copy, derive inside. Okay.
You plug into -1, yeah.
Now, what is that equivalent to? Yep, so P prime at -1 is
2 times, what is that?
1
-6.
plus 1 is 2,
-6.
-3, right? Okay, so what's F prime at 2?
Wait, is F prime at 2, not F prime at -6?
-1 squared is 1
Yeah.
minus -1.
But when you do the chain rule, it's not, it like separates it, so it's like now.
Oh, yeah.
It's
Yeah,
not
these are
part of the
separate.
inside of the function.
That-
Okay.
This is outside.
Because I would have thought it was
Separate.
still in the function, so I would evaluate it at 6.
Yeah,
Maybe it's-
separate. This has to be in the parentheses here with the 2, so. Okay, so what's F prime at 2? You know what, we might have goofed on the previous answer. What's the slope of that line? -2. So we go down 8 over 4, -2. Okay. We made a boo-boo somewhere. I believe it's right there.
Why G prime at 3?
G prime at 3 is F at 3. F at 3 is not -1, it is -2.
Oh.
Because we have a slope of -2 here.
Alright, I have to see this.
Okay, so, yeah, you're just working that relationship between functions, derivatives, and integrals. Right. So, like I always tell you, try to keep these as simple as possible. Because at their core, a lot of these problems are not very difficult if you just keep it simple. Because they can't give you really hard stuff and keep you on time for this AP exam. The biggest thing in the free responses is just play with that relationship and then know how to apply derivatives and integrals. And they're always going to throw something really hard at you. But it's usually like 5 points out of the 54, you know. We good?